All right, here we go. This is section 5.3 pre-calculus, video number 1. We're solving some solving equations that involve trig functions. We have 4 examples here that we're going to do, and that's it. Yeah, the tricky thing, or triggy thing, is we got to remember that sine, cosine, and tangent, all these trig functions, secant, cosecant, cotangent, they're all periodic functions, which means they repeat. So they're, like, if I want to know when like cosine of x equals 1/2, there's infinitely many solutions because, well, cosine of pi over 3 equals 1/2, cosine of 5 pi over 3 equals 1/2, and then if I add or subtract 2 pi however many times I want, I can get another angle that gives me a cosine of that angle equal to 1/2. So we'll get into that. I'm just going to jump in, do the examples. Hopefully that's enough to assist you with your homework and that sort of thing, and cover anything that you missed in class. So first problem. Here we have 2 cosine x minus root 3 equals 0. First thing we want to do is we want to solve to get cosine of x equals number. So in order to do that, I'm going to add root 3 to both sides. All right, get 2 cosine x equals square root of 3. And then I'm going to divide by 2, divide by 2, divide by 2. That gives me cosine of x equals square root of 3 over 2. All right, so what I want to do now is I want to find what numbers for x give me a cosine that's equal to root 3 over 2. So I'm going to go over my unit circle here, and I notice, right, cosine's the x value. When we're at pi over 6, the cosine of pi over 6 is square root of 3 over 2. So that's one of the answers. So x equals pi over 6. But, like, if I'm looking at the unit circle here, I could also, right, pi over 6, I could go, right, 13 pi over 6, right, go a whole 2 pi plus the pi over 6. And I could do that as many rotations as I want. So I'm going to say pi over 6 plus 2 pi n, and I'm going to say n is an integer. And the way we write this in math ways, we say n is an element, is contained in the set of integers, and it's that blackboard bold Z. It's like a Z, capital Z with a little double line there. Basically means n is an integer to positive or negative whole number. All right, so that's one of the possible answers. The other one, remember, we're looking at the cosines, we're looking at the x number. When is the x root 3 over 2? And that's also here at 11 pi over 6. So also x equals 11 pi over 6. And then once again, we're going to throw that plus 2 pi n in there to say, hey, it could be any of those values. Now, I just realized that I forgot to include in these examples a problem that has a multiple angle problem. Whoops. So I'm just going to quickly change one of these examples. And that's going to be this example. It'll be cosine of 4x 2 cosine 4x plus 1 equals 0. There we go. That'll be it. Okay. Sorry, I just realized that after I hit play or start on the video, so yeah. All right, let's go to the second problem here. Woo! Second problem is 4 sine squared x minus 3 equals 0. All right, so once again, we've got like the sine squared x instead of cosine x, but we want to isolate that trig function. So I'm going to add 3 and then divide by 4 here. I'm going to add 3 on each side, and then I'm going to divide by 4. Right, just undo what's happening to the sine squared, and I get sine squared x equals 3/4. Cool. Now I gotta give, this is sine squared. I want sine of x because I know information about sine. Sine is the y value on the unit circle. So I'm going to square root both sides of this equation. And when I square root, when I'm solving an equation, I need to remember that this could have been a positive or a negative, right? Because, well, we'll get there. I'm gonna say sine of x is positive or negative square root of 3/2. Excuse me. Ooh, that was a fun burp. Sorry, burp on camera. Rule. So square root of 3 is root 3. Square root of 4 is 2. That's where that root 3/2 comes from. And if I square positive root 3/2, I get 3/4. If I square negative root 3/2, I still get 3/4. So that's why we gotta have that plus minus in there. Anytime we square root in an equation, like as a solving a solving tool, we gotta have that plus or minus in there. So sine of x equals positive or negative root 3/2. Now we're like, all right, it's sine, so it's the y value on the unit circle. We go to our unit circle, aha, y value is root 3/2 at pi/3. So that's our reference angle that we want. So I'm gonna draw my little unit circle here. I'm gonna throw my pi/3 in there, but it's also, the sine or the y value is also root 3/2 at 2 pi/3. So this is when sine gives us positive root 3/2. We also want the negative root 3/2, right? So it's plus or minus. So that's going to happen down here and down here where both reference angles are pi/3 again. So here this is at 4 pi/3 and this is at 5 pi/3. Right, so all of these angles will give us a sine of x equal to either positive or negative root 3/2. Now, if you look at this, you're like, well, this angle and this, those make the same line, right? So if I take this and I add pi to it, I'm gonna get that angle. And same thing here. If I take this and I add pi to it, I'm gonna get that one. So here I can kind of make it easier on myself. Instead of writing down 4 angles with a plus 2 pi n, I can just write down these 2 angles and then add pi n. Because if I add pi to this angle, I get this angle. If I add pi to this angle, I get this angle. And that's because the pi, remember, is like 180 degrees. It makes a straight line when you add it. All right, so our answers here are x equals pi/3 plus 1 pi n. If I add pi to this, that gives me that 4 pi/3, where n is an integer, and then x equals 2 pi/3 plus pi n. If you wanted to, you could say plus 2 pi n plus 2 pi n, and then say 4 pi/3 plus 2 pi n, 5 pi/3 plus 2 pi n. It just takes longer to write, and the plus pi n gets all of them. Okay, so I'm going to erase these, we'll work on 3 and 4, and that'll be it for the video. So, here we go. Okay. Alright, problem 3. So here we have 2 cosine of 4x plus 1 equals 0. Alright, well, it's cosine of 4x. So the difference here is there's something else inside the parentheses other than just an x. We are still going to solve for cosine 4x first. So cosine 4x equals what? Go from there, and then we're going to get rid of that 4 as like our last step. So let's go ahead and do that. we're going to solve for cosine 4x. We're going to get rid of the plus 1. We're going to get rid of the multiply by 2 by subtracting 1 and dividing by 2. Right? That means cosine 4x equals negative 1/2. All right, let's get our unit circle out. And we know cosine is the x number. That's right here. When cosine is equal to positive 1/2, that's at pi over 3. So our pi over 3 is going to be our reference angle that we want here. But we're on the negative side. So we have a reference angle of pi over 3 here on the negative side, which means our big angle, or actual angle, is 2 pi over 3. And then because this is our x number of 1/2, right, we get this angle as well, because it's got the same x number, so the same cosine, which is at 4 pi over 3. So 2 pi over 3 and 4 pi over 3. So we have cosine 4x equals negative 1/2 when 4x equals 2 pi over 3 plus 2 pi n, or 4x equals 4 pi over 3 plus 2 pi n, and we're saying n is an integer here. Well, that's lovely. We have what 4x equals, but really we want what x is equal to. So what we're going to do is just undo the multiply by 4 on the x. So we just divide everything by 4 in both of them. Divide by 4, divide by 4, divide by 4. Everything gets divided by 4. That gives me here x equals, so I have a 2 pi over 4 times 3. 4 times 3 is 12. 2 divided by 12 is 6. So we have a pi over 6 plus 2 pi n over 4. The 2 and the 4 are going to cancel. And we're going to get a pi over 2n, right? Because 2/4 is 1/2. And then we're going to say, or x equals, here the 4 is just going to straight up cancel out, and we get pi over 3 plus that 2 over 4 once again is going to cancel out to 1/2, but we're going to go pi over 2 n, because there's still pi up there. And that will be our final answer there. Awesome. Cool, cool. Lastly, let's do problem 4 here, and then we'll call it good. So problem 4, we have tangent to the third x equals 3 tangent x. Right, now we got to remember here that tangent has a different period than sine and cosine. Remember, sine and cosine have a period of 2 pi. Tangent has a period of 1 pi. Okay. So first thing I want to do here is I notice I have tangent to the third, tangent to the first. I have powers of tangent. I'm going to get them on the same side of the equal sign and then factor and hope I can do some stuff with that. So I'm going to subtract a 3 tangent x off the left. If I can get it equal to 0 and factor, I can then use the zero product property, which is the goal here. So tangent to the third x minus 3 tangent x equals 0. All right, cool. Well, now I can factor out the tan x. So I'm going to factor the tangent x out. So I got to divide this by tangent x, which is going to give me tangent squared x. And I got to divide this by tangent x, which is going to give me a minus 3 equals 0. Cool. Well, now I have two things, tangent x and tan squared x minus 3 equal to 0. I can now use my zero product property. And whoop, I can say, hey, tangent x could be 0, or tan squared x minus 3 could equal 0. And now I got to solve both of these equations. Well, if tan x equals 0, then that means, remember, tangent represents the slope of the radius on the unit circle. That means the slope of the radius is 0. Well, where does that happen? That happens when x is 0. Also when x is pi, when x is 2 pi, when x is 3 pi, 4 pi. And remember, the period for tangent is 1 pi. So I can say 0 plus pi n, which is just pi times n, once again, where n is an integer. Now to solve tan squared x minus 3 equals 0, I'm going to add 3 to both sides. Boop, boop. That gives me tangent squared x equals 3. I gotta undo the squared part by square rooting. Don't forget about the positive negative. So that gives me tangent of x equals positive or negative square root of 3. Now remember, we're talking about tangent, which is the slope of the radius. And when we're looking at our unit circle, we have slope of 0, slope of 1, slope undefined. Here we have a slope that's between 0 and 1. Here we have a slope that's between 1 and really big number. Square root of 3 is bigger than 1, right? Because if we square 1 and we square 3, right, we get 3 instead of 1. 3 is bigger, right? So pi over 3, tangent of pi over 3 is square root of 3. And then for a negative root 3, that would be over here at 2 pi over 3. So that's going to give me x equals pi over 3 plus pi n. Remember, it's just pi n because tangent has a period of pi, so it'll repeat every pi. And then x equals 2 pi over 3 plus pi n. This pi over 3 is for the positive root 3. This 2 pi over 3 is for the negative root 3. So this whole thing right here is my final answer. All right, hopefully that is enough to guide you through the homework. And if you missed any class, right, hopefully that this fills in the gaps. Remember, I have office hours, right? Email me. Let me know if you have questions. All right, thanks for watching. Have a wonderful day.